Welcome to this tutorial video. In this tutorial video, we want to look at how we use Hess's law to calculate the enthalpy change. So we have been given the question which reads, given the enthalpy change of the following reactions, so we have these three reactions, we have been asked to calculate the enthalpy change of the reaction which is shown here. Let us remind ourselves how we state Hess's law. Hess's law states that the enthalpy change of the overall reaction is equal to the sum of the enthalpy changes of individual steps. So let's see how we apply that principle. So we'll examine these three different reactions and see what we can do to these reactions to come up with this overall reaction which we have been asked to calculate its enthalpy change. When you look at this reaction, we have the reactant parts and the product part. So if you identify the reactant and the product part, you look at the individual reactions that you have been given the enthalpy changes. So we have three different reactions that we have been given the enthalpy changes. Our goal is to use our analytic skills to come up with this equation using these three equations. So do not follow these equations in the step they are in. To say you should first start with this one, then followed by this one, then this one. Look at which equation can you start with to help you come up with the overall reaction. So in this case, I can start with equation 2. Now, why am I starting with equation 2? Have noticed that there is a product which has NO. Equation 2 has NO in it, which is here. So this product is in equation 2. Now, in equation 2, this product is a reactant. Hess's law helps us to know that we can reverse this reaction and make this reactant to become a product. So let's reverse the second one. We are saying we reverse the second reaction. Now, when we reverse the second reaction, what are we going to see? You'll see that we'll have 2, then NO2, which is a gas, which produces 2NO gas plus oxygen gas. Now, when you reverse the reaction, the enthalpy change also is reversed. So at this point, the enthalpy change then becomes, the enthalpy change of this reaction becomes positive 113.1 kilojoules. At this point, you can see that now NO is a product and the enthalpy change has been changed. The sign here was negative, now it is positive. Now, when you look at the overall reaction that we have, NO has 3. Now, let's think that the first equation has NO that has 2. So, what further action can we take regarding the second reaction? We can reduce this NO to 1 so that when we add this 2 and the 1 we have reduced here can give us the 3. So how do we reduce this NO, which is 2, to 1? You simply multiply this reaction by half. This should be done also with the enthalpy change. So let's multiply the whole reaction by half. What are we going to have? We'll have NO2, which is the gas. This 2 simplifies with the half. It's giving us here we'll have NO gas plus half of oxygen gas. Now, if you do this, even the enthalpy change, we should now have half of the enthalpy change of the first reaction. So we are simply saying, 113.1 divided by 2. It is giving us the enthalpy change of 56.55 kilojoules. So this becomes the enthalpy change of first reversing the second reaction, then secondly multiplying the second reaction by half. Remember one point. We have said we want to have a total of 3 NOs in the overall reaction. And we said we have reduced this one by 1, then the 2 NOs are coming from the first reaction. So this simply means that the first reaction, we are not going to change anything from it. So the first reaction then, we'll say the way it is, it will remain the way it is, which is N2 gas plus O2 gas, giving us the product which is 2NO gas. The enthalpy change of this one is 180.7 kilojoules. So remember, this 2NO and this NO, it gives us the 3NO that we are targeting to have on the product side. Let us now look at what we can do to reaction 3 so that we look at the reactant side. When you look at the reactant, N2O has 1 molar ratio, while reaction 3 has 2 as the molar ratio there. So what can we do to this reaction to reduce it to 1? We can multiply this reaction with half. So if we say reaction 3, we are multiplying it by half, what are we going to do? If all of this is multiplied by half, we are simply saying even the enthalpy change there is multiplied by half. So when you multiply that by half, we'll have N2O, which is a gas, producing N2, which is a gas, and half of oxygen gas there. Now, if we do this, we are saying even the enthalpy change should be multiplied by half. So we are saying negative 163.2. When you are multiplying it by half, you are getting the enthalpy change of negative 81.6 kilojoules. So this becomes the enthalpy change of multiplying reaction 3 by half. At this point, you can now try to simplify the 3 reactions and see if you can come up with the overall reaction. Now, our goal is, after we simplify these 3 reactions, we should come up with the overall reaction. If we fail to come up with the overall reaction, then we need to inspect what we have done and see changes that can be done to come up with the overall reaction. Now, what do we mean that we can simplify these reactions? Let's look at reaction 2, reaction 1, and reaction 3. Are there some products or reactants that we can remove from this reaction? Yes, look at this one. Nitrogen here. This one can simplify with this nitrogen here. What else can we simplify? Can you see that we have this half oxygen and this half oxygen? So half plus half gives you 1, which simplifies with this 1 oxygen there. After you have that, is there anything that we can simplify? No. So what are we remaining with? The first thing we are remaining with is this one as a reactant, that is N2O, which is the N2O that we have here. The second thing we have remained with is NO2, which is NO2, which is here. Last but not least, we have remained with 2NO and 1NO. So 1 plus 2 gives us 3NO. So this simply means that we have done the correct work in terms of rearranging these reactions, reversing them, and multiplying them with half. Now, remember what we said about the enthalpy changes regarding to Hess's law. It tells us that the overall reaction is equal to the sum of individual steps that you can do to come up with the overall reaction. So what are we simply saying? We now have to add this enthalpy plus this enthalpy and this enthalpy. Let's add the three enthalpies, that is 56.55 plus 180.7 plus negative 81.6. This gives us the total enthalpy change of 155.65 kilojoules. So this becomes the overall enthalpy change of this reaction. In summary, what have we looked at in this video? The target that we have when you have been given the question to calculate the enthalpy change and you have been given different reactions is to analyze what steps can be done to the reaction that you have been given to come up with the overall reaction. If any of the reaction is multiplied by 2, even the enthalpy change should be multiplied by 2. If any of the reaction is divided by 2, even the enthalpy change should be divided by 2. If any of the reaction is reversed, even the sign of the enthalpy change should be reversed. Please note that in some questions, not all the reactions need to be used. In this one, we used every reaction that was in the question, but not all reactions need to be used in some questions. Your target is to come up with the overall reaction. After you come up with the overall reaction, you simply add the sum of the enthalpy changes of those reactions that you have used to come up with the overall enthalpy change of the reaction.